Mars isn't just another planet, it's a cosmic puzzle box, waiting to be cracked open. Picture this: a world where the sunsets are blue, where dust devils taller than skyscrapers whirl across barren plains, and where the very ground beneath your feet might hide secrets that rewrite everything we thought we knew about our place in the universe. This isn't science fiction, this is Mars, our enigmatic neighbor, a place that's both hauntingly familiar and utterly alien, and despite decades of exploration, it keeps throwing curveballs that leave even the brightest minds scratching their heads. Think about it, we've sent rovers, landers, and orbiters to study this rusty red world, and yet, with every new discovery, the mysteries only deepen. From strange, glowing orbs dotting the landscape to bizarre rock formations that look eerily sculpted, Mars refuses to play by the rules. Some of these findings are so baffling, so downright weird, that they've sparked debates, conspiracy theories, and even whispers of the impossible. What if Mars isn't just a dead planet? What if it's hiding clues to something far bigger, something that could change how we see our own origins? That's exactly what we're diving into today. Over the years, scientists have cataloged dozens of anomalies on Mars, 30, to be exact, that defy easy explanation. Some might be tricks of light and shadow, while others could be hints of something far more extraordinary. So buckle up, because we're about to take you on a journey across the Martian surface, uncovering its strangest, most mind-bending secrets. By the time we're done, you'll see Mars in a whole new light, and you might just find yourself questioning what's really out there, waiting to be discovered. Imagine a face staring back at us from another world, a colossal visage carved into the rocky surface of Mars, its hollow eyes and solemn expression frozen in time. That's exactly what scientists thought they'd found in 1876, when NASA Viking 1 orbiter snapped an image of the Pareidolia region that sent shockwaves through the scientific community and beyond. At first glance, the structure looked uncannily like a human face, complete with symmetrical features: a nose, a mouth, even what appeared to be a headdress. The photograph ignited a firestorm of speculation. Was this proof of an ancient Martian civilization, a monument left behind by some long-lost culture? Or just a trick of light and shadow playing on our desperate search for familiarity in the unknown? For decades, the face on Mars became a cultural phenomenon, fueling countless books, documentaries, and even blockbuster films. But as technology advanced, so did our ability to scrutinize this Martian enigma. Higher-resolution images from missions like Mars Global Surveyor and Mars Reconnaissance Orbiter revealed the truth: the face was nothing more than an ordinary mesa, a natural rock formation eroded by wind and time. The shadows that once gave it such eerie, human-like contours were just that, shadows, stretching across the rugged terrain in a way that fooled both our eyes and our imaginations. Yet even with the evidence laid bare, the mystery refuses to die. Conspiracy theorists still argue that NASA is hiding the truth, that the later images were doctored to cover up something monumental. And in a way, they're not entirely wrong, just not in the way they think. The real story here isn't about hidden aliens, it's about us. The face on Mars is a perfect example of Pareidolia, the human brain's tendency to see familiar patterns where none exist. We're wired to find faces in clouds, in toast, even in the rocks of another world. It's a quirk of perception that tells us more about our own minds than it does about Mars. But here's the twist: while the face itself may be a natural formation, the region around it is still packed with geological oddities that scientists can't fully explain. Strange pyramid-like structures dot the landscape, and the terrain is riddled with features that don't quite match typical erosion patterns. Could there be a more mundane explanation? Almost certainly, but that's the thing about Mars, it keeps us guessing. Every time we think we've unraveled one mystery, another takes its place, whispering the tantalizing question: what if we're not alone in the universe after all? The Martian surface isn't just a barren wasteland, it's a treasure trove of geological oddities, and few are as peculiar as the so-called blueberries spotted by NASA Opportunity Rover. These tiny, spherical formations littered the landscape like scattered beads, their smooth, rounded shape standing out starkly against the rust-colored dust. When Opportunity first rolled up to them in 2004, scientists were stunned. What were these strange little orbs, and how did they end up scattered across Mars like nature's own marbles? Turns out these blueberries, officially known as hematite concretions, are more than just curiosities. Hematite is an iron oxide mineral that typically forms in the presence of liquid water, and that's where things get really interesting. On Earth, similar formations are often found in sedimentary rocks where groundwater once flowed, slowly depositing minerals layer by layer until these tiny spheres took shape. The fact that Mars has them, that's a big clue pointing to a watery past, one where lakes, rivers, or even vast oceans might have shaped the planet's history. But not everyone was convinced right away. Some researchers initially argued that volcanic activity or even meteorite impacts could have created the blueberries, sparking debates that lasted for years. Then came the kicker. Detailed analysis showed the spheres were too perfectly shaped, too evenly distributed, to be anything but water-related. The evidence piled up, and today, these unassuming little orbs are some of the strongest proof we have that Mars wasn't always the dry, desolate world we see today. It was once alive geologically, at least, with water coursing through its veins. Yet even with the mystery mostly solved, the blueberries still hold surprises. Some are clustered in dense patches, while others appear in isolation, as if some ancient Martian current had carried them there, and their size, ranging from mere millimeters to the width of a pencil eraser, each one a tiny time capsule from a vanished era. It's almost poetic, these small, unassuming spheres silently testifying to a time when Mars might have been as vibrant as Earth, its surface shimmering with liquid water under a pale pink sky. So the next time you look up at Mars in the night sky, remember, it wasn't always a desert. Once it may have been a world of rivers carving valleys, of waves lapping against shores, and of tiny blueberry-like stones forming in the quiet depths of ancient waters. And who knows, maybe, just maybe, those same waters held something even more extraordinary, something we've yet to discover. One day, Opportunity was doing what it did best, snapping images of the Martian terrain, when something impossible happened. The rover's cameras captured a photo of a particular patch of ground, and then, just 12 days later, another image revealed a rock that hadn't been there before. Not just any rock, mind you. This one was pale, almost white, and shaped bizarrely like a jelly donut, its smooth sides contrasting sharply with the surrounding rusty landscape. Scientists dubbed it Pinnacle Island, and its sudden appearance sent researchers into a frenzy. How does a rock just materialize out of nowhere on a planet without rain, earthquakes, or any obvious geological activity? Theories flew fast and furious. Some suggested the rover itself had kicked it up while maneuvering, though Opportunity's path didn't quite line up with the rock's location. Others proposed wind had nudged it into view, except Mars' thin atmosphere makes strong gusts rare, and the rock was oddly heavy for that explanation to hold up. Then came the wilder ideas. Had it been ejected by a distant meteor impact, or worse, was this some kind of Martian creature lurking just beneath the surface? Okay, probably not, but the mystery only deepened when scientists analyzed the doughnut's composition. It was packed with sulfur and magnesium, elements that suggested it had been hiding underground, untouched by the planet's harsh surface conditions for who knows how long. The most plausible answer: Opportunity had unknowingly flipped the rock while driving. One of its wheels likely clipped a buried edge, popping Pinnacle Island into view like a cosmic jack-in-the-box. But here's the kicker: even if the rover did dislodge it, that means the rock had been sitting just beneath the surface, preserved in a way that's incredibly rare on Mars. It's like stumbling across a time capsule. one that gives us a pristine look at the planet's ancient chemistry, yet the doughnut rock leaves us with a bigger question: how many more of these geological surprises are hiding right under our rover's wheels, waiting to be uncovered? Mars has a way of keeping its secrets buried literally until we accidentally trip over them, and each time we do, it's a reminder of just how little we truly know about this enigmatic world. High on the slopes of Mount Sharp, the Curiosity rover captured an image that set the internet ablaze: a narrow, rectangular crevice carved into the rock face, so perfectly geometric it looked like a doorway straight out of an ancient temple. The photo, snapped in May 2022, showed a shadowy slit just tall enough for a person to walk through, flanked by smooth, almost engineered-looking walls. Social media erupted. Had we finally found proof of intelligent life on Mars? Was this some long-abandoned entrance to an underground city? Or worse, had we stumbled upon something we weren't meant to see? Scientists, of course, had a far less dramatic explanation. What appeared to be a crafted doorway was, in reality, a completely natural fracture in the rock, a byproduct of the planet's relentless geological history. Here's how it works. Mars, much like Earth, experiences stress fractures caused by shifting tectonic forces, temperature extremes, and even meteor impacts over millennia. This particular crevice likely formed when a slab of rock sheared away from the cliffside, leaving behind a clean, sharp break, the rectangular shape. Just a coincidence of angles and erosion, the same way a shattered pane of glass can sometimes leave behind eerily straight edges. But let's dig deeper, because the real fascination here isn't the crevice itself, but why our brains so desperately want it to be a door. This phenomenon, known as simulacra, is the tendency to interpret random patterns as meaningful images, like seeing a face in the clouds or a dragon in the stars. It's the same psychological quirk that made us see the face on Mars. Our minds are hardwired to seek order in chaos, to find intention where there is none. And on a planet as alien as Mars, that instinct goes into overdrive. Curiosities' team even pointed out the scale. The doorway is barely a foot tall when you account for the rover's perspective. Hardly big enough for a civilization of advanced Martians, yet the allure persists, and that's the beauty of it. Mars doesn't just challenge our scientific understanding, it plays with our imagination, dangling riddles that blur the line between geology and mythology. And while this particular mystery has been settled, it leaves us with a tantalizing thought: if a simple crack in the rock can spark such wonder, what else might be hiding in plain sight, waiting for us to misread it, or to finally see it for what it truly is? The Curiosity rover was trundling across Mars' Gale crater when its cameras captured something that sent the internet into a frenzy: a small, fuzzy shape nestled among the rocks, with pointy ears, a whiskered snout, and even what looked like tiny paws. Within hours, the Mars rat became a viral sensation, with viewers convinced they were staring at photographic proof of life on the red planet. The resemblance was uncanny right down to the way sunlight cast shadows that made the rock appear to have fur. But before you start drafting plans for the first interplanetary petting zoo, let's take a closer look at what was really going on. This is Pareidolia in action, the same mental shortcut that makes us see dragons in clouds or faces in power outlets. Our brains are wired to prioritize visual patterns linked to survival, like recognizing predators or interpreting social cues from facial expressions. That's why we're so quick to spot familiar shapes, even in completely random formations. On Earth, it's harmless fun. On Mars, it fuels decades of speculation. The rat was just a wind-sculpted rock, likely basalt or another volcanic stone, eroded over eons into a shape that happened to trigger our pattern recognition software. Scientists quickly debunked the rodent theory, pointing out the scale. The rat was barely the size of a baseball and the utter absence of other biological clues. No droppings, no burrows, no signs of movement, but here's where it gets interesting. The rock's texture tells a story of its own. The pitted surface, visible in high-resolution images, suggests it was sand-blasted by Martian dust storms, while its elongated shape hints at ancient fractures in the planet's crust. This tiny, rat-shaped anomaly is actually a geological time capsule, preserving clues about Mars' violent weather and volcanic past, yet the Mars rat phenomenon reveals something bigger than just a quirky rock. It highlights how desperately we project Earth's familiarities onto alien landscapes. Every log, statue, or animal spotted in Rover photos reflects our hunger for connection, for proof that we're not alone. And while science marches on, dissecting each anomaly with hard data, the allure of these mysteries persists, because somewhere between cold facts and wild imagination lies the real magic of Mars, a world that keeps challenging us to question, to wonder, and sometimes to see rats in rocks. The Martian sunlight glinted off something unnatural, a sleek, metallic fragment lodged in the rust-colored soil, so out of place it looked like it had fallen from the sky. When Curiosities' cameras zoomed in on the anomaly in 2012, the discovery sent mission control into a frenzy. Here, in the middle of Gale Crater's ancient wasteland, was a thumb-sized object gleaming with the telltale sheen of polished metal. Internet sleuths immediately proclaimed it proof of extraterrestrial technology, while conspiracy theorists whispered about secret Martian factories. The truth, as always with Mars, was far stranger than fiction. Initial analysis revealed the fragment wasn't alien at all, it was a tiny piece of the rover itself, likely a shred of protective casing or wiring that had shaken loose during landing. But the real twist, this wasn't even the first time Curiosity had stumbled across its own debris. Months earlier, it had spotted a similar metallic fleck nicknamed Pinnacle Island's cousin, confirming that human-made artifacts were now part of Mars' geological record. It's a surreal thought. Our machines are literally leaving marks on another world, scattering fragments that future explorers might one day mistake for natural features. Yet the story doesn't end there. Over the years, Mars rovers have encountered other metallic oddities with far more exotic origins. Take the basketball-sized meteorite dubbed Lebanon, discovered by Opportunity in 2014. Unlike the rover's lost screws, this hunk of iron and nickel had traveled billions of miles through space before crash landing on Mars. Its smooth, glassy surface, forged in the vacuum of space, bore tiny pits called rigmaglypts, thumbprint-like indentations carved by superheated gases, as it screamed through the Martian atmosphere. These cosmic leftovers are time capsules from the early solar system, offering clues about the violent processes that shape planets like Mars. What makes these metallic mysteries so fascinating isn't just their origin, it's how they force us to rethink the very definition of natural on Mars. The planet's surface is now a patchwork of both ancient geology and human geology, where meteorites older than life itself lie side by side with shreds of Earth-born machinery. Every glint of metal tells a dual story, one of cosmic chaos and another of our relentless drive to explore, and perhaps that's the most poetic revelation of all. Mars isn't just a museum of the solar system's past, it's becoming a living archive of humanity's first tentative steps beyond our homeworld, so the next time you see a flash of silver in a rover's photo, remember, it might be a relic of the universe's birth, or a fleck of human ambition. Either way, it's proof that Mars is no longer just a distant dot in the sky, it's a place where our stories, both cosmic and personal, are slowly being written into the dust. Amid the dull, rocky landscape of Gale Crater, Curiosity's cameras spotted something delicate and unexpected, a tiny, intricate structure blooming from the Martian soil, like a fragile flower frozen in time. When the image hit Earth in early 2022, the internet lit up with theories. Was this proof of alien plant life, a fossilized remnant of some ancient Martian organism? The truth, as it often is on Mars, was both more ordinary and more extraordinary. This otherworldly flower turned out to be a mineral formation, likely a type of crystalline structure known as a diagenetic feature. Here's how it probably formed. Over millions of years, mineral-rich water seeped through cracks in Mars' bedrock, depositing tiny particles layer by layer. As the water evaporated or the conditions changed, these minerals crystallized into intricate, organic-looking shapes. The result, a structure so finely branched, so eerily lifelike, that it's easy to mistake it for something biological. But this was geology at its most artistic, a masterpiece carved by chemistry and time. What's fascinating isn't just the formation itself, but what it tells us about Mars' hidden history. Diagenetic features like this one are essentially fossilized fingerprints of the planet's watery past. They form in environments where liquid water interacts with rock, meaning this tiny flower is yet another clue that Mars was once a far wetter, more dynamic world. And it's not alone. Similar structures nicknamed blueberries and cauliflowers by scientists have been found scattered across the Martian surface, each one a tiny time capsule preserving the story of the planet's ancient chemistry. But here's where it gets even weirder. Some researchers argue these formations might resemble terrestrial microbial structures called stromatolites, layered rocks created by ancient bacteria on Earth. Could the Mars flower be a hint of something similar? Probably not, but the resemblance is uncanny enough to keep scientists digging. Because if there's one thing Mars loves to do, it's dangle just enough ambiguity to keep us questioning what's really possible. So while this delicate bloom isn't proof of life, it is proof of something just as compelling. Mars, even in its barren state, is a world of hidden beauty and complexity. A place where minerals mimic life, where geology blurs into art, and where every new discovery reminds us that the red planet still has countless secrets left to spill. The Martian landscape often looks like something ripped from the pages of a fantasy novel, but few features sell that illusion more than the so-called dragon scales of the Murray butts. Picture this, a series of jagged, plate-like formations jutting from the rust-colored soil, their edges overlapping like the armored hide of some colossal, slumbering beast. When Curiosity rover rolled up to this surreal terrain in 2016, scientists were staring at what looked less like geology and more like the aftermath of an epic battle between mythical creatures. But the truth behind these scales is even more fascinating because they're not the work of dragons, but of ancient winds and waters that once shaped Mars in ways we're only beginning to understand. These eerie formations are actually the remnants of ancient sedimentary rock, layers upon layers of dust and sand that accumulated over millions of years when Mars was a far wetter world. Over time, groundwater likely cemented these deposits together, forming dense, resistant slabs. Then, as the planet dried up and its atmosphere thinned, relentless winds began sandblasting the softer material around them, leaving behind these jagged, scale-like protrusions. It's erosion at its most artistic nature's equivalent of a sculptor chiseling away at marble to reveal the masterpiece within. What makes the dragon scales especially intriguing is how they mirror Earth's own geological oddities. The Utah Desert's Goblin Valley boasts similar formations where wind and water have carved brittle rock into bulbous, otherworldly shapes, but on Mars, the effect is magnified by the planet's lower gravity and thinner atmosphere, allowing erosion to create even sharper, more exaggerated features. Every ridge and crevice tells a story, a timeline of climatic shifts, of oceans that vanished and skies that faded from blue to pink, yet the real magic lies in the details. Close-up images reveal delicate cross-bedding within the scale's subtle diagonal lines that curve like frozen waves. These are the fingerprints of ancient Martian river deltas, or lake beds, where flowing water once dragged sediments into rhythmic patterns. Now, billions of years later, those same patterns are etched into the rock-like hieroglyphs, waiting for us to decode them. It's as if Mars is whispering its history to anyone patient enough to look closely. So while the dragon scales might not belong to an actual beast, they're proof of something just as awe-inspiring. Mars was once a world alive with motion, where rivers carved canyons and winds shaped monuments that outlasted civilizations. And curiosities tire tracks winding through them, that's our species leaving its own faint mark beside the scars of time, jutting out from a Martian cliffside, suspended impossibly in midair as if defying gravity itself, was what appeared to be a gleaming silver spoon. When Curiosities Masscam captured this bizarre sight in 2015, the internet collectively lost its mind. How could a perfectly spoon-shaped rock float above the surface of Mars without any visible support? The image looked like a surrealist painting, a cosmic still life where the laws of physics had taken a coffee break, but the truth behind this celestial cutlery is a masterclass in how light, shadow, and erosion can conspire to fool even the most discerning eyes. This so-called spoon is actually a skinny finger of rock, painstakingly carved by millennia of Martian winds. The illusion comes from its orientation protruding horizontally from the cliff with a bulbous end that mirrors the shape of a spoon's bowl, while its handle tapers into the rock face. With the sun positioned just right, shadows blend seamlessly with the surrounding terrain, making the connecting point vanish. It's the same trick magicians use when they levitate objects on stage, hide the support, and the eye fills in the gaps with wonder. What's fascinating isn't just the spoon itself, but how common these gravity-defying formations actually are on Mars. The planet's thin atmosphere might not pack the punch of Earth's winds, but over millions of years, even gentle breezes can sculpt sandstone into impossible-looking arches, overhangs, and bridges. Back in 2017, Opportunity spotted another head-scratcher, a rock balanced precariously on a narrow pedestal, dubbed the Mars Snowman for its wobbling, top-heavy appearance. These aren't glitches in the matrix, they're testaments to erosion's patience, whittling away softer material grain by grain until only the most resilient structures remain. Scientists call these formations ventifacts, rocks polished and shaped by wind-blown sand. On Earth, they're found in deserts like Namibia's Skeleton Coast, where coastal gusts have sculpted boulders into sleek, alien shapes. But Mars takes it to another level. Without rain or tectonic activity to disturb the process, wind erosion works uninterrupted for eons, creating features that would be fleeting novelties on our planet. That floating spoon, it might cling to its perch for thousands more years before finally crumbling to dust, yet the spoon's greatest trick isn't levitation, it's reflection. Like so many Martian mysteries, it holds up a mirror to our own biases. We see a spoon because our brains are steeped in a world of human-made objects, primed to spot tools and artifacts even where none exist. It's the same impulse that made early astronomers map canals on Mars or mistake Viking lander cables for snakes. The red planet teases out our hunger for familiarity, reminding us that exploration isn't just about discovering new worlds, it's about confronting the limits of our own perception. So the next time you see a headline screaming about cutlery on Mars, remember, the universe is weirder than fiction, but rarely so literal. That spoon won't stir alien tea, but it just might stir something deeper in us, a reminder that wonder often lies in the space between what we see and what we want to see. The Martian terrain has thrown us countless curveballs, but few caused as much of a stir as the infamous thigh bone, photographed by Curiosity in 2014. There it was, a smooth, elongated rock jutting from the dust, its rounded edges and tapered shape uncannily resembling a fossilized femur. The internet erupted. Had we finally found proof of ancient Martian giants? Was this the smoking gun for extraterrestrial life that conspiracy theorists had been waiting for? NASA inbox flooded with demands for answers, while tabloids ran headlines screaming about skeletal remains on the red planet, but science, as always, had a far more grounded explanation. What looked like a bone was nothing more than a wind-sculpted stone, shaped by millennia of abrasive Martian gusts. Here's how it works. Mars' thin atmosphere might not pack the punch of Earth's hurricanes, but what it lacks in force, it makes up for in persistence. Over millions of years, Even gentle winds loaded with fine dust can sandblast rocks into surreal shapes, curves, grooves, and even hollows that mimic biological structures. This particular rock likely started as a chunk of volcanic basalt, fractured and then polished by countless dust storms until it took on that eerily familiar form. The real smoking gun scale, when you account for the rover's perspective, the femur, is barely the size of a human finger, hardly evidence of towering Martian creatures. And texture tells the same story. Close-ups reveal pitted surfaces and angular fractures, classic hallmarks of mechanical weathering, not cellular decay. Even the colors a giveaway. True fossilized bone on Earth, stained by minerals over time, tends to darken or discolor, while this rock's rusty hue matches the iron oxide-rich soil surrounding it. Yet the thigh bone debate highlights something deeper than just mistaken identity. It's a case study in how desperately we project Earth's biology onto alien landscapes. Our brains are fine-tuned to spot patterns tied to survival, faces in shadows, predators in rustling leaves, and that instinct doesn't switch off just because we're looking at another planet. Pareidolia strikes again, urging us to see life where there's only geology, but here's the twist: while this bone is definitely just a rock, its existence still speaks volumes about Mars' dramatic past. The fact that Wines could sculpt it so precisely hints at an atmosphere thick enough to sustain erosion for eons, back when liquid water might still have flowed. And that's the real takeaway. Sometimes, the most ordinary seeming stones hold extraordinary stories. They're not relics of Martian dinosaurs, but they are relics of a world that was once dynamic enough to carve them. Even in the vast, empty deserts of Mars, the universe sometimes winks at us, like the time NASA Mars Reconnaissance Orbiter spotted a sand dune so perfectly shaped, it looked like it had been pulled straight out of a sci-fi franchise. There, etched into the rusty plains of the Hellas Basin, was a towering dune in the unmistakable form of a chevron, a near-perfect replica of the iconic Starfleet logo from Star Trek. The resemblance was uncanny, a crisp, symmetrical delta with a pointed tip and flared wings, as if some cosmic prankster had pressed a Vulcan seal into the Martian sands. Of course, this wasn't the work of interstellar Starfleet cadets, just another dazzling coincidence sculpted by Mars' relentless winds. The dune's shape is a textbook example of what geologists call a barchan, a crescent-shaped dune commonly found in deserts with limited sand supply and consistent wind direction. On Earth, barchans pepper landscapes like Namibia's Skeleton Coast, marching across the terrain like wind-driven dominoes, but on Mars, where the thin atmosphere and lack of vegetation allow for sharper, more exaggerated features, this particular dune's wings stretched into that eerily familiar arrowhead silhouette. The real magic lies in the physics behind it. Barchan dunes form when winds blow steadily from one direction, pushing sand grains up the gentle slope of the dune's windward side. As the grains reach the crest, they tumble down the steeper leeward face, creating that signature crescent shape, but in rare cases like this one, small variations in wind patterns or underlying topography can stretch one side of the dune longer than the other, morphing the crescent into a near-perfect chevron. It's a fleeting alignment, a momentary harmony of erosion and airflow that, in this case, lasted just long enough for us to snap a photo. Fans of Star Trek immediately lost their minds, joking about secret Starfleet bases or time-traveling landing parties. But scientists were equally fascinated for a different reason. Dunes like this are more than just pretty shapes, they're wind veins on a planetary scale. By studying their orientation and movement, researchers can map Mars' atmospheric currents with startling precision. Every curve and ripple encodes data about wind speed, particle size, even seasonal weather shifts. That Star Trek dune, it's not just a pop culture Easter egg, it's a dynamic record of the planet's ever-changing climate. Yet the coincidence still begs the question, why does Mars keep serving up these moments of uncanny familiarity? From faces to flowers to sci-fi logos, the red planet seems determined to mirror our own cultural symbols. Maybe it's because we're hardwired to seek the known in the unknown, or maybe, just maybe, the universe has a sense of humor. Either way, every time Mars winks at us like this, it's a reminder that exploration isn't just about finding answers. Sometimes it's about stumbling into moments of pure, delightful wonder where science and imagination dance in the desert, leaving footprints shaped like starships. Rolling across the Martian plains, Curiosities' wheels kicked up dust, and then, like a cosmic game of marbles, the rover spotted something strange. Nestled among jagged rocks was an almost perfectly spherical stone, its smooth surface gleaming under the harsh sunlight. Scientists dubbed it the Mars Cannonball, and at first glance, it looked like it had been shot from some interplanetary battleship. But this wasn't evidence of an alien artillery range. It was a natural wonder, one that mirrors some of Earth's most fascinating geological quirks. The cannonball's secret lies in its formation. Back on Earth, we see similar spherical rocks in places like Utah's Makwi marbles or Japan's dragon's eggs, iron-rich concretions that form when mineral-laden water seeps through porous rock. Over time, the minerals, often hematite or goethite, accumulate around a central nucleus, growing outward in concentric layers like an onion. The result: a rock so perfectly round it seems handcrafted. On Mars, the process likely played out the same way, just with a far older timeline. Billions of years ago, when groundwater still flowed beneath the planet's surface, dissolved minerals could have slowly collected around a pebble or grain of sand, layer by patient layer, until the cannonball took shape. But here's where Mars throws us a curve. The planet's lower gravity and thinner atmosphere mean erosion happens differently there. Without the constant scouring of wind and rain we experience on Earth, spherical rocks on Mars can retain their pristine shapes far longer, almost frozen in time. That's why Curiosity's cannonball looks so uncannily new: no weathering to wear down its edges, no vegetation to obscure its form. It's a snapshot of a process that might have taken millions of years, preserved in the Martian dust. Yet even among these eerie similarities, there's a tantalizing difference. Earth's spherical rocks often form in sedimentary basins where water was once abundant: shallow seas, river deltas, or lake beds. The fact that Mars has them too, that's another quiet nod to its wetter past. But here's the kicker: some of these Martian spheres are denser, richer in certain minerals than their Earth counterparts, hinting at chemical processes we're still unraveling. Maybe the water was more acidic, or the mineral concentrations higher. Every round rock is a clue, a tiny time capsule holding secrets about the planet's lost oceans. So next time you see a photo of the cannonball, don't just marvel at its shape, think about the forces that made it. A drop of water here, a grain of sand there, and an entire planet's history written in stone. Literally, remember the infamous doughnut rock, that pale, jelly-like oddity that mysteriously appeared in front of Opportunity? Well, years later, armed with fresh data and high-resolution scans, scientists peeled back another layer of its secrets, revealing why this bizarre formation stood out like a sore thumb against Mars' rusty landscape. Spectral analysis showed the rock was packed with sulfur, magnesium, and manganese elements that typically form in watery environments where minerals concentrate over time. Its smooth, almost polished surface suggested it had been sheltered underground, untouched by the abrasive dust storms that weathered the surrounding rocks into jagged, pitted shapes. What's wild is how different its chemistry was compared to everything around it. While most of Mars' surface rocks are basaltic volcanic leftovers stained red by iron oxide, the doughnut was more like a geological outlier, a stubborn relic of a wetter era. Think of it as a time capsule with two stories to tell. First, its spherical shape hinted at a formation process similar to Earth's riverbed concretions, where minerals slowly clump around a central nucleus in flowing water. Second, its sudden appearance suggested the rover might have flipped it from a hidden layer of sediment, one that hadn't seen sunlight for possibly billions of years. But the real kicker, the doughnut wasn't alone. Subsequent scans revealed more of these pale, rounded rocks scattered nearby, half buried like a cache of ancient marbles. Some were even richer in sulfates, compounds that often form as water evaporates, a tantalizing clue that this patch of Mars might have once been the shoreline of a long-vanished lake. So while the doughnut's debut was baffling, its true legacy isn't just about one weird rock. It's a breadcrumb leading us closer to answering the bigger question: how much of Mars' past was shaped by the one ingredient we know fuels life, water. And here's the twist: scientists now think these elusive, sheltered rocks might be the key to finding organic material. Their mineral-heavy compositions could have acted as natural preservatives, shielding fragile molecules from radiation. That means every time a rover's wheel accidentally kicks one loose, we're not just unearthing a geological oddity, we might be cracking open a vault of cosmic secrets, one jelly doughnut at a time. On the edge of a vast Martian plain, nestled among wind-scoured rocks, lies a geological oddity that looks less like something from another planet and more like a doodle from a child's science notebook, a tadpole. Not an actual amphibian, of course, but a peculiar, teardrop-shaped depression stretching over half a mile long, complete with what appears to be a tail curling behind it. When NASA Mars Reconnaissance Orbiter first spotted this feature in 2017, scientists were staring at a puzzle written in the language of erosion, impact, and maybe even fire. At first glance, the tadpole's shape suggests a dramatic origin story, like a meteorite striking the surface at a shallow angle, gouging out an elongated crater before skipping away. On Earth, we see similar scars, like Arizona's meteor crater, where oblique impacts create asymmetrical wounds in the landscape, but Mars' tadpole might have a more layered tale to tell. High-resolution images reveal rugged, textured walls around the depression, hinting at something more complex than a simple impact. The tail, for instance, isn't just a smooth groove, it's riddled with smaller pits and ridges, as if whatever formed it interacted violently with the terrain. Then there's the volcanic angle. Mars is home to some of the solar system's most colossal volcanoes, and their eruptions could have sculpted bizarre features like this. Picture a lava tube collapsing unevenly, or a vent explosively spewing molten rock, leaving behind a twisted, tadpole-shaped sinkhole. The region where it's found, the volcanic plains of Elysium Planitia, adds weight to this idea, a landscape still echoing with the planet's fiery past. But erosion might be the real artist here. Mars' thin atmosphere doesn't stop its winds from carving rock over geologic time. The tadpole's smooth, rounded edges suggest centuries of sandblasting, while its unusual form could be the result of harder rock layers resisting the wind's touch, leaving softer material to be sculpted into that whimsical shape. It's a reminder that even on a planet where water once flowed, wind can be the most patient sculptor of all. What makes the tadpole special isn't just its origin, it's the questions it raises. If it's an impact crater, why don't we see more like it? If volcanic, what unique conditions shaped it so distinctly? And if erosion's the main force, why hasn't time erased it completely? Every anomaly like this is a breadcrumb leading us deeper into Mars' geologic memoir, a story where every chapter seems to rewrite what we thought we knew. So while it may not be an actual tadpole, it's proof that Mars' past was anything but stagnant, a world of impacts, eruptions, and winds fierce enough to carve poetry into stone. Perched on the edge of a Martian ridge, a circular formation rises from the dust, its concentric rings and textured surface so uncannily resembling a petrified tree stump that it's hard not to do a double take. When NASA Perseverance rover captured this peculiar feature in 2023, the internet exploded with theories. Had Mars once hosted forests? Was this fossilized evidence of an ancient ecosystem? The truth, as always with the Red Planet, is a masterclass in how geology can mimic biology with breathtaking precision. What appears to be a tree stump is actually a marvel of layered sedimentation. Over millions of years, Wind and water deposited fine particles in this spot, compacting them into rock. Then erosion went to work whittling away softer material while leaving behind harder, more resistant layers. The result, those concentric rings that mirror tree growth lines aren't organic at all. They're pages in a geologic diary, each band marking shifts in climate or sediment composition. It's the same process that carves Utah's hoodoos or Arizona's wave nature, using wind and water as chisels to sculpt illusions that tease our Earth-centric biases. The stump's texture offers even more clues. High-resolution images reveal pits and grooves inconsistent with biological decay, but perfectly aligned with how sandstone weathers under relentless dust storms. On Earth, such features are common in arid deserts where wind abrasion sandblasts rocks into surreal shapes, but Mars adds a twist. Its lower gravity and thinner atmosphere allow erosion to create sharper, more exaggerated forms. That stump-like silhouette isn't a relic of life, it's a monument to persistence, shaped by eons of whispering winds, yet the most fascinating detail lies in the context. This formation sits near Jezero Crater's ancient river delta, a region once flush with water. While it's not a tree, its layered structure still whispers secrets about Mars' wetter past. Similar sedimentary patterns on Earth form in riverbeds or lake shores, where flowing water sorts particles by size, creating distinct bands. So while this stump won't rewrite biology textbooks, it might just fill another piece in the puzzle of Mars' hydrological history, one that suggests water didn't just exist here, it shaped landscapes in ways we're only beginning to decode. The real lesson here isn't about Martian forests, it's about perception. Our brains, honed by evolution to spot life, keep projecting Earth's templates onto alien worlds. And Mars, ever the trickster, indulges us dangling mirages of faces, flowers, and now stumps, only to remind us that reality is stranger than imagination. Because in the end, a rock that fools us into seeing a tree is far more wondrous than an actual tree would be. It's proof that nature's artistry transcends planets, weaving illusions to humble and delight those willing to look closely enough. Rising from the dusty plains of Mars like an ancient monument, a towering formation caught the eye of the Curiosity rover, its triangular silhouette so crisp, its slope so symmetrical, it could easily pass for a pyramid built by some long-lost civilization. When images of this structure hit Earth in 2015, they sparked a firestorm of speculation. Had we stumbled upon evidence of Martian architects? Or was this the work of something even more extraordinary, nature itself, sculpting the impossible? The truth is almost as fascinating as fiction. This so-called Mars pyramid is actually a small mountain, roughly the size of a car, carved by billions of years of wind erosion. But how does nature produce something so eerily geometric? The secret lies in the rock's composition. Made of layered sedimentary deposits, this formation was likely once part of a larger outcrop. As Martian winds scoured the landscape, they exploited tiny weaknesses in the rock, wearing away softer material while leaving behind harder, more resistant layers. Over eons, this relentless sandblasting honed the structure into those uncanny pyramid-like facets. It's the same process that creates Earth's flat-topped mesas or the razor-edged peaks of the Grand Canyon, just amplified by Mars' thin atmosphere and lack of weather to soften the edges. What makes this pyramid special isn't just its shape, but what it tells us about the planet's history. Those precise layers, they're like pages in a geologic diary, recording shifts in climate, volcanic activity, or even ancient water flow. Some scientists argue the formation's sharp angles suggest the rock is exceptionally hard, possibly volcanic, basalt, or another dense material that resisted erosion while everything around it crumbled. Others point to the way fractures in the rock could have guided the wind's carving, like a sculptor following the grain of marble. But here's where it gets wild. Similar pyramid-shaped formations exist on Earth, from the towering Matterhorn to Egypt's natural pyramid mountains, like Mount Babel in Algeria. The difference: On Earth, rain, ice, and vegetation eventually round off the sharp edges. On Mars, without these smoothing forces, the angles stay crisp, frozen in time like a snapshot of erosion's artistry. So while this pyramid wasn't built by Martians, it's still a monument, just not to aliens. It's a testament to the patient, invisible hand of wind, a force that can carve mountains into geometry if given enough millennia. And perhaps that's the real wonder here. Mars doesn't need ancient architects to awe us. Its natural landscapes are mysterious enough. Lurking among Mars' dusty rocks like a sunbathing reptile, the so-called Mars iguana became an overnight sensation when Curiosities cameras spotted it in 2013. With what appeared to be scaly skin, a pointed snout, and even a curled tail, this formation looked less like a random boulder and more like a petrified creature caught mid-scuttle. The internet erupted with claims that NASA had finally found life on the red planet, or at least its fossilized remains, but as with so many Martian mysteries, the truth is both simpler and more fascinating than fantasy. This iguana is textbook Pareidolia, our brain's habit of stitching random shapes into familiar patterns. Just as we see animals in clouds or faces in mountain ranges, the Martian landscape serves up endless Rorschach tests, and our minds can't resist filling in the blanks. Zoom in though, and the illusion shatters. The scales are just wind-carved ridges on a weathered rock, the tail, a trick of shadow stretching across uneven terrain. What felt like a eureka moment was really geology's sly nod to our hunger for connection, yet there's brilliance in the banality. The rock's texture, pitted and grooved like lizard skin, is a diary of Martian weather. Those intricate patterns, they're the handiwork of dust storms, each microscopic grain sand-blasting the surface over millennia. On Earth, similar features form in deserts like Chile's Atacama, where relentless winds sculpt stone into surreal shapes. But Mars' thinner atmosphere exaggerates the effect, creating sharper, more dramatic etchings that beg to be misread. What makes the iguana special isn't its resemblance to wildlife, but what it reveals about erosion's artistry. Unlike Earth, where rain and vegetation soften rock features, Mars preserves every windstroke with eerie precision. That reptilian texture could be billions of years old, a fossilized snapshot of ancient weather patterns. And here's the kicker: while it's definitely not an iguana, its formation might still hint at life-friendly conditions. The same processes that carved this rock, wind, and water erosion, once shaped environments where microbial life could have thrived. So next time you spot a creature in Martian imagery, remember, the real magic isn't in seeing iguanas where none exist. It's in recognizing how a planet's silent, slow-motion dance with time can create mirages vivid enough to fool even the most skeptical minds. Mars isn't just a world of rocks, it's a master illusionist, and we're its eager audience, forever mistaking shadows for stories. Sticking out from Mars' dusty surface like a forgotten breakfast, the so-called waffle rock stopped scientists in their tracks when Curiosities cameras spotted it in 2018. This bizarre formation bore an uncanny resemblance to a giant, fossilized waffle, complete with a grid of deep, intersecting ridges that formed near-perfect squares across its surface. The internet, predictably, lit up with jokes about Martian brunch culture, but the real story behind this peculiar rock is a fascinating lesson in how nature can craft geometry worthy of a diner menu. So how does a planet create something so unnervingly precise? The leading theory points to a phenomenon called boxwork, where minerals fill cracks in bedrock, then outlast the surrounding softer rock as erosion wears it away. Imagine Mars billions of years ago. Volcanic activity or shifting tectonic forces fracture the planet's crust, creating a network of intersecting fissures. Over time, mineral-rich groundwater seeps into these cracks, depositing hardy materials like silica or iron oxides. Fast forward to today, and the softer rock that once encased these vein-like structures has been scoured away by wind, leaving behind the rigid, grid-like skeleton we see now. On Earth, similar formations appear in places like South Dakota's Wind Cave, where calcite boxwork creates honeycomb patterns on cave walls, but there's another possibility: sedimentary layering. Mars was once a world of swirling rivers and deep lakes, and flowing water can sort sediments into rhythmic patterns, alternating layers of coarse and fine particles, compressed over eons, might have created stress points that eroded unevenly, resulting in those waffle-like compartments. The rover's instruments could hold the answer. If the ridges are richer in certain minerals than the surrounding rock, it'd support the boxwork theory. If not, we might be looking at a masterpiece of ancient hydrology. What makes this waffle truly extraordinary isn't just its shape, but its endurance. Unlike Earth, where rain and vegetation would quickly soften such delicate features, Mars' arid climate has preserved them with razor-sharp clarity. Those ridges might have formed when liquid water still pooled on the surface, making them potential time capsules from a warmer, wetter era. And here's the kicker: similar mineral veins found elsewhere on Mars, like those in Gale Crater, have been found to contain sulfates, a telltale sign of past water activity. So while this rock won't be serving syrup anytime soon, it's far from a cosmic novelty. It's a snapshot of Mars' geological creativity, proving that even without chefs, the universe has a way of whipping up curiosities that defy expectations. And somewhere between volcanic tantrums and patient rivers, the red planet baked itself a waffle, one that just might help us crack the recipe for its ancient, watery past. One day in 2014, as Curiosity beamed back its routine snapshots of Mars' bleak landscape, something in the frame stood out like a flare in the night, a tiny, brilliant speck of light, shimmering on the horizon with an intensity that defied explanation. The image spread like wildfire, with some claiming it was proof of intelligent activity, a signal, a beacon, even the glow of some hidden Martian outpost. NASA's response was swift. It was likely just a cosmic ray striking the camera's sensor or sunlight glancing off a reflective rock, but like so many Martian mysteries, this one refused to fade into the mundane without a fight. The technical explanation makes perfect sense: cosmic rays, high-energy particles zipping through space, constantly bombard Mars' surface, and when they collide with camera sensors, they can leave behind bright pixelated streaks or spots. It's the same phenomenon that sometimes causes tiny bursts of static in deep space photography. Sunlight reflections are another possibility. With no atmosphere to diffuse the light as thoroughly as Earth's, even a sliver of reflective mineral could catch the sun at just the right angle and blaze like a tiny torch against the rust-colored plains. Yet what makes the Mars light so tantalizing isn't just the anomaly itself, it's the context. This wasn't the first time a rover had caught something luminous in its lens. In 2019, Curiosity photographed another eerie gleam, this one resembling a distant lamp hovering above the terrain, and back in 2005, Spirit's cameras captured a similar glow, later attributed to sunlight bouncing off dust particles. Each incident followed the same script: initial excitement, scientific debunking, and yet that lingering whisper of doubt. Here's where the intrigue deepens. If these lights were just cosmic rays or reflections, why don't they appear more frequently? Mars rovers take thousands of images, yet these glimmers remain rare, making them statistical outliers. And then there's the clustering. Some researchers note that certain regions, like Gale Crater, seem to produce these anomalies more often, hinting that local geology might play a role we don't yet fully understand. Could particular minerals or ice formations focus sunlight in unusual ways, or is there an atmospheric phenomenon at work, some quirk of Martian weather that bends light unpredictably? The truth is, Mars excels at creating illusions. Its thin air and lack of moisture let light behave in ways that would be impossible on Earth, and with no cities or streetlights to compare against, every gleam feels monumental. But that's the beauty of these mysteries: they push us to look closer, to question our assumptions. Even if the Mars light is nothing more than a cosmic ray's fleeting kiss on a camera sensor, It's a reminder that the universe loves to flirt with our curiosity, dangling riddles just out of reach to keep us searching for answers. Crouched among the rocks of Mars Murray Butts, a strange silhouette lurked, a cluster of boulders that, when caught at just the right angle, transformed into something eerily alive. With a rounded body, spindly protrusions splayed like legs, and even what appeared to be a pair of claws, this formation became known as the Mars crab. When Curiosities Masscam snapped the image in 2016, it didn't take long for the internet to erupt with theories. Had we stumbled upon some armored Martian crustacean, frozen in time, or was this yet another cosmic prank, another case of our brains playing tricks on us in the alien wilderness? This crab, of course, is pure geology, a textbook example of Pareidolia, the psychological phenomenon that makes us see faces in clouds or animals in mountain ranges. Our brains are hardwired to seek patterns, especially ones tied to survival. Spotting predators in dappled sunlight or recognizing food sources in cluttered environments kept our ancestors alive, and that instinct hasn't disappeared just because we're looking at another planet. The irony: the more barren and unfamiliar the landscape, the harder our minds work to fill the void with the familiar. Mars, with its rust-colored wasteland and wind-carved oddities, is the ultimate canvas for this mental sleight of hand. Zoom in, though, and the illusion unravels. Those claws are jagged rock fragments, likely broken off from a larger outcrop by thermal stress. In Mars, wild temperature swings cause rocks to expand and contract, splitting them along fractures. The body is just a weathered boulder, its rounded shape sculpted by sand-laden winds over millennia. Even the crab's texture, which at a glance might resemble a chitinous shell, is nothing more than pitting from micrometeorites or chemical weathering. It's a masterclass in how erosion and chance can conspire to create the uncanny, but here's where it gets fascinating. Pareidolia isn't just a quirk, it's a scientific tool. Early humans used it to navigate by spotting animal shapes in constellations. Modern astronomers use it to identify galaxies and telescope noise. Even NASA scientists occasionally lean on it when scanning Rover images for standout features. The crab, then, isn't just a glitch in perception, it's a reminder that our pattern-seeking brains drive discovery, even when they occasionally lead us down rabbit holes. Yet the Mars crab also underscores a deeper truth about exploration. Every time we project Earth's biology onto alien geology, we're revealing our own biases. We hunt for crabs and iguanas because they're part of our terrestrial vocabulary, but what if Mars once hosted life so alien, so unlike anything we know, that we're blind to its fossils? The crab may be a rock, but it's also a metaphor, a signpost pointing to the limits of our imagination as we search for life in the cosmos. So while this particular crustacean won't be scuttling across the Martian sands anytime soon, it's far from meaningless. It's a snapshot of the human mind at work, wrestling with the unknown, and in that struggle we're not just exploring Mars, we're exploring what it means to see, to wonder, and to sometimes mistake shadows for stories. Nestled among the jagged rocks of Mars Mount Sharp lies an object that looks like it was ripped straight from a horror movie, an elongated, rectangular boulder so perfectly shaped, it's been dubbed the Mars Coffin. When Curiosity rolled past this eerie formation in 2016, the internet seized on its uncanny resemblance to a burial casket, complete with a lid-like top and what appeared to be seams running along its sides. The image ignited a firestorm of speculation, from ancient Martian burial rituals to derelict spacecraft left behind by some forgotten civilization. But as with so many Martian mysteries, the truth lies in the interplay of light, shadow, and the human brain's relentless hunger for meaning. At first glance, the coffin's straight edges and rigid proportions seem too precise for nature to have crafted, but Mars is a master of illusion, and this formation is no exception. The rock's box-like appearance comes down to a trick of perspective and erosion. Likely a fractured slab of sandstone or volcanic basalt, This boulder was once part of a larger outcrop before weathering wind, temperature fluctuations, and possibly even ancient water, split it along natural fault lines. Over time, the element sanded its edges into those unnervingly sharp angles, while shadows cast by the low-hanging Martian sun accentuated the illusion of a crafted lid and base. It's the same geological magic that creates Earth's tessellated pavements in Tasmania or the hexagonal columns of Iceland's basalt cliffs, nature's way of turning chaos into geometry. What makes the Mars coffin especially mesmerizing is its isolation. Unlike similar formations on Earth, which often appear in clusters, this lonely boulder sits like a monolith against the barren landscape, amplifying its otherworldly vibe. Without surrounding context, no trees, no shifting light, our brains latch onto its symmetry as something deliberate, and here's the kicker: measurements reveal the rock is only about 3 feet long, far too small to be an actual coffin. But scale doesn't matter when our pattern-hunting instincts kick in. The coffin also highlights a paradox of Martian geology. The same forces that carve these crisp shapes, wind erosion, thermal stress, are also erase them over time. That this rock has retained its structure suggests it's made of unusually hard material, possibly cemented by mineral-rich groundwater billions of years ago. Every angle and fracture is a clue, not about aliens, but about the planet's violent past, volcanic eruptions, meteor impacts, and climates extreme enough to split mountains. Yet the coffin's greatest trick isn't its shape, it's what it reveals about us. We see caskets and faces and crabs because Mars is a mirror, reflecting our own stories back at us. In its emptiness, we fill the void with the only vocabulary we have, Earth's, and maybe that's the real lesson here. The red planet doesn't just challenge our science, it tests our imagination, daring us to tell the difference between what's there and what we desperately wish to see. So while the Mars coffin won't be holding any alien pharaohs, it's far from a dead end. It's a monument to perception, a rocky Rorschach test reminding us that sometimes the most alien thing about Mars isn't its landscape, it's how relentlessly human we remain when we stare into the unknown. Peering through the dusty veil of Mars' rocky plains, the Opportunity rover once captured an image that sent imaginations into overdrive, a formation so eerily humanoid, it was instantly dubbed the Mars statue. There, stark against the rust-colored backdrop, stood what appeared to be a slender figure with a rounded head, narrow shoulders, and even the suggestion of draped robes, frozen mid-stride as if waiting for someone or something to notice. The internet exploded with theories: an ancient monument, a lost civilization's guardian, even a stranded traveler from another world. But as with so many Martian mysteries, the truth is a masterclass in how our brains conspire with light and shadow to spin stories from stone. Zoom in and the statue's illusion unravels. That humanoid silhouette is nothing more than a wind-sculpted rock, barely a foot tall, its familiar shape carved by centuries of abrasive gusts. Mars' thin atmosphere might not pack Earth's wind force, but over millennia, even gentle breezes laden with fine dust can sandblast rocks into uncanny shapes. The head is a weathered knobby protrusion, the shoulders and robes are jagged edges where softer layers eroded unevenly, and that sense of motion. Pure perspective, the rover's angle and the sun's low glare cast shadows that exaggerate the rock's posture, turning a static lump into what feels like a figure caught in mid-movement. But here's where the mystery deepens. This isn't the first time a rover has spotted something eerily human-like. Spirits, Martian Yeti, and Curiosities, preying alien, followed the same script. Pareidolia, our brain's habit of imposing familiar shapes on random patterns, working overtime in an alien landscape. It's the same quirk that makes us see faces in clouds or animals in constellations. The difference, on Mars, where every rock is a potential clue to life, these illusions carry weight. Our hunger for connection transforms geology into mythology, whispering tales of statues where there are only stones. the real twist lies in the technology behind the illusion. Early rover cameras, with their lower resolution and limited angles, often amplified these misinterpretations. A blurry pixel here, a shadow there, and suddenly, a rock becomes a relic. Modern instruments like HiRISE on the Mars Reconnaissance Orbiter can snap images sharp enough to distinguish a pebble from a penny, yet even they occasionally produce head-scratchers. It's a reminder that exploration isn't just about better cameras, it's about learning to see Mars on its own terms, not through the lens of our terrestrial biases. Yet buried in this statue's story is a tantalizing scientific nugget. The rock's composition, likely volcanic basalt or sandstone, hints at the region's fiery or watery past, depending on its texture. If it's pitted and grooved, it might have been sandblasted by ancient dust storms. If layered, it could be sediment from a long-vanished lake. Even as Pareidolia fools us, the geology beneath the illusion holds real clues about Mars' evolution. That statue might not be an artifact, but it's still a time capsule, preserving secrets of the planet's turbulent history. So while the Mars statue won't be greeting future astronauts with open arms, it serves a far richer purpose. It's a mirror reflecting our own hopes and fears onto the red planet's barren canvas. Every time we mistake wind for artistry or erosion for intention, we're reminded that exploration is as much about understanding ourselves as it is about decoding another world. And perhaps that's the most Martian lesson of all: the universe doesn't owe us familiar shapes, but it will always reward those who look closely enough to see beyond them. Stretching across the Martian surface like the scorched veins of a dying world, vast tube-like formations have sparked debates that blur the line between geology and science fiction. These so-called Mars tunnels, photographed by orbiters like Mars Reconnaissance Orbiter, appear as dark, snaking channels, some wide enough to swallow entire city blocks, others tapering into shadowy fissures that vanish underground. At first glance they look eerily deliberate, their smooth walls and consistent width suggesting the handiwork of some advanced civilization, but the reality reveals something far more explosive. These are the scars of Mars' volcanic fury, frozen in time and mistaken for something far more sinister. These tunnels aren't hollow conduits but collapsed lava tubes, formed when rivers of molten rock surged beneath the planet's surface billions of years ago. Here's how it works: during volcanic eruptions, lava cools rapidly at the edges, forming a solid crust while the molten interior continues flowing. Eventually, the lava drains away, leaving behind an empty tunnel. Over time, the ceiling collapses in sections, creating those distinctive chains of pits and trenches we see today. On Earth, we find similar structures in Hawaii's Kazumura Cave or Iceland's Surchalir, just on a much smaller scale. Mars, with its weaker gravity and lack of tectonic recycling, preserves these features like a museum of its fiery youth. What makes these tunnels extraordinary isn't just their size, some stretch for hundreds of miles, but what they imply about the planet's potential to harbor life. Lava tubes shield their interiors from radiation, meteorite impacts, and temperature extremes, creating subsurface oases where microbial life could theoretically survive even today. In fact, NASA Perseverance rover has studied similar formations near Jezero crater, hunting for mineral deposits or chemical traces that might hint at ancient habitability. The tunnel's walls, rich in basaltic rock, could even trap pockets of water ice, turning them into accidental refrigerators for organic material. Yet the wildest twist comes from how these geological ghosts fuel speculation. Their linear precision and repetitive arches seem almost architectural, igniting theories of underground Martian cities or even evidence of past colonization. Even scientists admit the resemblance is uncanny, though they're quick to point out that nature needs no blueprints to create order. Wind erosion can sculpt symmetry. Lava follows the path of least resistance with mathematical efficiency. But the allure persists because buried in these debates is a tantalizing truth. Whether natural or not, these tunnels are shelters, and if humanity ever colonizes Mars, we might not build our habitats from scratch. We might just move into the ruins of the planet's volcanic past, repurposing its ancient fury as our future refuge. So while these tunnels aren't proof of alien engineers, they're monuments to something just as profound: Mars' ability to shape its own destiny, carving highways of fire and then abandoning them to time. And who knows, one day we might walk those shadowed corridors ourselves, tracing the footsteps of a planet's explosive history, or writing the first chapters of our own. Lying flat on the Martian soil like a discarded dinner plate, the so-called Mars disk stopped scientists in their tracks when Curiosities cameras spotted it in 2021. This bizarre, near-perfect circle of rock, roughly the size of a car tire, seemed almost polished against the surrounding rubble, its smooth edges and uniform thickness defying the usual chaos of wind-sculpted geology. At first glance, it looked less like a natural formation and more like something deliberately crafted, sparking instant comparisons to everything from meteorite remnants to ancient alien artifacts. But as with so many Martian mysteries, the truth lies somewhere between cosmic coincidence and planetary processes we're only beginning to understand. One compelling theory points to volcanic origins. On Earth, explosive eruptions can blast out volcanic bombs, chunks of molten rock that solidify mid-air into aerodynamic shapes, sometimes even forming disks as they spin through the atmosphere. Mars, home to the solar system's largest volcanoes, could have produced similar projectiles billions of years ago during its fiery prime. If the disk is one of these relics, its smoothness might come from the intense heat rounding its edges during flight, while its preservation could be thanks to Mars' lack of erosion, no rain or vegetation to wear it down over eons. But there's another possibility: impact debris. When meteorites strike Mars at oblique angles, they can shatter surface rock into high-velocity fragments that skip across the terrain like stones on a pond, carving out flat, circular shapes in their wake. The disk's composition, high in silica or basalt, based on spectral analysis, could confirm whether it's a local rock sheared by impact or a foreign meteorite fragment itself. Intriguingly, similar shatter cones found in Earth's impact craters mirror this disk's radial fractures, hinting at a violent birth. Then there's the wind's role. Mars' thin but persistent winds can sandblast rocks into startlingly symmetrical shapes over millennia. The disk's uniform thickness suggests it might have once been part of a larger sedimentary layer that eroded around it, leaving this resistant slab isolated. On Earth, Namibia's fairy circles and Australia's desert pavements show how wind and time can conspire to create geometric oddities, just rarely with this level of precision. What makes the Mars disk truly fascinating isn't just its shape, but its context. Found near an ancient stream bed in Gale Crater, it sits in a region that was once flush with water. Could flowing liquid have contributed to its formation, tumbling it smooth like a river-worn pebble, or does its presence hint at a more explosive, volcanic past for this seemingly tranquil valley? Every fracture line and mineral deposit on its surface is a cipher waiting to be decoded, a whisper from Mars' geological heyday. So while this disk won't be spinning on any alien turntable, it's far from ordinary. Whether volcanic projectile, impact survivor, or wind's masterpiece, it's a testament to the red planet's ability to sculpt the uncanny, and perhaps that's the real lesson here: Mars doesn't need artificial mysteries to captivate us. Its natural ones are strange enough, towering above the Martian plains like nature's own pyramid. The Mars staircase unfolds in a series of near-perfect, staggered ledges carved into the slopes of Gale Crater. When Curiosity first beamed back images of this terraced marvel, the internet buzzed with wild theories. Could these be the ruins of an ancient ziggurat, or perhaps steps leading to some long-lost underground chamber? The truth, as always with Mars, is a breathtaking blend of time, chemistry, and relentless erosion working in concert, to create something that feels almost intentional. These stair-like formations are textbook examples of sedimentary layering, a geological process as familiar to Earth as it is alien on Mars. Picture this: billions of years ago, Gale Crater was a vast lakebed, its waters quietly depositing layer upon layer of silt, sand, and mineral-rich sediments. Each flood, each seasonal shift left behind a new stratum, like pages in a planetary diary. Then, as Mars dried up and its atmosphere thinned, winds and occasional flash floods began their patient dissection. Softer layers eroded faster, leaving behind the harder, more resistant shelves that now form these cosmic steps. It's the same process that carved the Grand Canyon's terraces, just slowed to a Martian pace, where a single step might take 1,000,000 years to form. But here's where it gets fascinating. Unlike Earth's staircases of stone, which are often softened by rain and vegetation, Mars' steps remain razor-sharp. The planet's weak gravity and thin air allow for startlingly precise erosion, creating edges so crisp they look laser-cut. Close-up images reveal cross-bedding diagonal lines within each layer that hint at ancient currents or wind patterns, frozen in time. Some steps even glitter with mineral deposits like gypsum, suggesting water once percolated through these rocks, leaving behind crystalline fingerprints as it vanished into the void. What makes this staircase truly extraordinary isn't just its origin, but what it reveals about Mars' habitability. Those layered sediments, they're a climate archive. Thick layers might indicate prolonged wet periods, thin ones could mark droughts, and nestled between them could be organic molecules, trapped like insects in amber. In fact, Curiosities drills have already found carbon signatures in similar formations, building blocks of life preserved in this rocky ledger. Yet the greatest marvel lies in perspective. From orbit, these steps seem monumental, but on the ground they're often no taller than a curb. It's a reminder that Mars' grandeur is as much about illusion as reality, a world where geology mirrors art, and every shadow tells a story. So while no Martians carved these stairs, there's still a pathway to the past, inviting us to climb deeper into the planet's mysteries, one ancient layer at a time. Peering through the Martian dust, Opportunity's cameras once locked onto a rock that made even seasoned scientists do a double take, a formation so eerily reminiscent of a human skull, it instantly became known as the Mars alien skull. With hollowed eye sockets, a pronounced nasal cavity, and even what appeared to be a jawline, this bone-white fragment looked like it had tumbled straight out of a horror movie. The internet predictably lost its collective mind. Had we finally stumbled upon fossilized remains of a Martian, or was this the grim relic of some ill-fated explorer from a lost civilization? The truth, as always, lies in the interplay of light, shadow, and the human brain's relentless habit of seeing faces where none exist. Zoom in, and the skull's sinister illusion unravels. Those eye sockets, just wind-carved pits in a volcanic rock, likely basalt or sandstone, sculpted by centuries of abrasive dust storms, the jawline. A fractured edge where the rock split along natural fault lines, its angular break catching the sunlight at just the right angle to mimic a skeletal curve. Even the skull's pale hue isn't supernatural, it's the result of sun-bleached minerals or a coating of fine dust, giving it that ghostly pallor against the rust-colored terrain. This is Pareidolia at its most persuasive, our brain's hardwired tendency to impose familiar shapes, especially faces, onto random patterns. It's why we see dragons in clouds or the man in the moon. On Mars, where every rock is an unfamiliar silhouette against an alien sky, this instinct goes into overdrive. The skull's features align perfectly with our evolutionary bias for spotting faces, a survival tool that once helped our ancestors detect predators in dense foliage. Now it turns Martian geology into a cosmic Rorschach test, but here's where the real science shines. The skull's texture tells a story far more compelling than any alien conspiracy. Close-up images reveal pockmarks from micrometeorites and striations from wind erosion, clues to the planet's violent weather history. Its elongated shape suggests it might have once been part of a larger outcrop. Shattered by thermal stress, Mars' wild temperature swings cause rocks to expand and contract, fracturing them like ice cubes in a glass. And that unsettling whiteness, spectral analysis suggests it could be silica or hydrated minerals, remnants of a time when groundwater might have percolated through these stones, leaving behind chemical ghosts. The skull's greatest trick isn't its resemblance to bone, it's how it mirrors Earth's own geological oddities. In Egypt's white desert, wind-sculpted chalk formations uncannily resemble human profiles, while Nevada's Apollo face rock famously fooled hikers into thinking they'd found an ancient statue. The difference on Earth, rain and vegetation eventually soften these illusions. On Mars, with no weather to blur the edges, the illusion stays razor-sharp, frozen in time like a fossilized joke. So while this skull won't be starring in any interplanetary Halloween specials, it's far from meaningless. It's a testament to erosion's artistry, a reminder that nature needs no aliens to create the uncanny. And perhaps that's the real revelation here. Mars doesn't just challenge our science, it plays with our psychology, dangling riddles that say less about its secrets and more about our own hunger to find meaning in the unknown. After all, if a windswept rock can become a skull, what other illusions are waiting out there, just one camera angle away from rewriting our cosmic story? Jutting from the Martian rocks like nature's own barbed wire, rows of jagged spikes have puzzled scientists and conspiracy theorists alike. When Curiosities cameras zoomed in on these bizarre formations in 2022, the images revealed slender, metallic-looking protrusions, some as thin as pencils, others as thick as fingers clustered together like the spines of an otherworldly sea urchin. At first glance they seemed almost manufactured, their sharp angles and uniform alignment defying the chaos of natural erosion, but Mars, as always, had a geological trick up its sleeve. These spikes aren't the work of alien blacksmiths, they're masterpieces of mineral precipitation. Here's how it likely happened. Billions of years ago, mineral-rich groundwater seeped into cracks and pores in Martian rock. As the water evaporated or chemical conditions shifted, dissolved minerals like hematite or gypsum crystallized, growing outward in needle-like formations. Over time, wind erosion stripped away the softer surrounding rock, leaving these hardy metallic filaments exposed like nails hammered into stone. On Earth, we see similar phenomena in places like Nevada's hoodoos, where iron-rich veins weather into spiky crowns, or Mexico's Cave of Crystals, where selenite shafts erupt from the walls like frozen lightning. But Mars adds its own twist. The planet's ultra-thin atmosphere means these spikes avoid the smoothing effects of rain or frost, preserving their razor edges with eerie precision. Some even gleam in the sunlight, their surfaces polished by millennia of dust storms into a metallic luster that fools the eye. Spectral data from Curiosities ChemCam confirms their composition, iron oxides and sulfates, common byproducts of water-rock interactions. That's the real revelation. These spikes are more than curiosities. They're chemical fingerprints of Mars' wetter past, tiny monuments to an era when liquid water percolated through these very rocks. Yet the mystery deepens when you consider their arrangement. Unlike Earth's random mineral growths, many Martian spikes align in near parallel rows, as if following some invisible blueprint. The likely culprit, ancient stress fractures in the bedrock. Just as tree roots follow cracks in pavement, these mineral veins may have exploited weaknesses in the rock, creating orderly armies of spines where the planet's crust once trembled. It's a haunting echo of Mars' violent youth, frozen in iron and time. Of course, not all spikes play by the rules. Some curve like claws, their shapes warped by shifting groundwater chemistry. Others cluster in dense thickets, suggesting localized mineral hotspots, and then there are the outliers, solitary spikes jutting at odd angles, their isolation hinting at freak erosion events or even micrometeorite impacts. Each variation whispers a different chapter in Mars' geological saga, proving that even the smallest features can hold epic stories. So while these spikes won't be snagging any Martian fishing nets, they're far from mundane. They're relics of a planet that refused to rust quietly, forging beauty from chaos, one crystallized droplet at a time, and if you listen closely, their silent, metallic chorus might just tell us where and how to search for the echoes of life. Buried in the Martian dust, a tiny ripple of rock stops scientists dead in their tracks, a segmented, worm-like curve that, at just the right angle, appeared to be the fossilized remains of some ancient creature. When Curiosity first glimpsed this formation in 2018, the grainy black and white images sparked immediate comparisons to Earth's most primitive fossils. The resemblance was unsettling. Those regular ridges looked almost like the segmented exoskeleton of a trilobite or the coiled imprint of a prehistoric mollusk. For a breathless moment, it seemed humanity might be staring at the first concrete evidence of extraterrestrial life, but Mars, as usual, had other plans. What makes this fossil debate so fascinating isn't just the rock itself, it's the razor-thin line between biology and geology in an alien environment. On Earth, we identify fossils through a checklist of traits, microscopic cellular structures, chemical signatures like concentrated carbon, and patterns too complex to form without life's guiding hand. The Mars formation fails all three tests. High-resolution scans reveal the ridges are composed of sulfate minerals, likely deposited by evaporating water billions of years ago. Their rhythmic pattern, a quirk of crystallization when mineral-rich fluids dry up, they can precipitate in repeating bands, like salt crusting the rim of a glass. Even the curve that initially suggested a worm's body is textbook concretion, where minerals cement around a central nucleus, creating organic-looking lobes. Yet the story doesn't end with simple debunking. This fossil sits in Gale Crater, once the floor of an ancient lake. While it's not biological, its very existence points to a time when Mars had the right ingredients for life: liquid water, mineral diversity, and stable environments where chemistry could run wild. Intriguingly, similar sulfate formations on Earth, like those in Chile's Atacama Desert, often form alongside actual microbial fossils. The minerals themselves become life traps, preserving organic material in their crystalline grasp. So while this Martian mimic isn't proof of life, it's a neon sign pointing to where we should keep looking. The deeper lesson here is about perception. Fossil hunting on another planet forces us to confront our Earth-tinted biases. Our only frame of reference for life signatures comes from a single data point, our own planet's history. What if Martian life, if it ever existed, followed such alien biochemical rules that its fossils look nothing like ours? We might be staring right at them, blind to their true nature. That's why scientists now dream of bringing samples home, where labs can probe for subtler clues, isotope ratios, molecular asymmetries, or other traces no camera could ever spot. So while this particular rock won't be starring in any alien museum exhibits, it crystallizes a profound truth. Mars isn't just challenging us to find life, it's forcing us to redefine what life even looks like. And sometimes the most important discoveries aren't the answers we uncover, but the questions we learn to ask. Rising from the Martian plains like a silent sentinel, the so-called Mars monolith stands as one of the red planet's most striking optical illusions. When NASA Mars Reconnaissance Orbiter first captured this bizarre formation in 2009, the image sent shockwaves through both scientific and pop culture circles. There, perched atop a dusty plateau, was a towering, rectangular slab, its razor-straight edges and stark silhouette evoking instant comparisons to the mysterious monolith from 2001, A Space Odyssey. Almost immediately, theories exploded. Was this proof of alien engineering, a cosmic calling card left behind by some advanced civilization, or had nature itself sculpted the perfect geometrical prank? What makes this formation so mesmerizing is its uncanny precision. Unlike most wind-carved rocks on Mars, which show rounded edges and irregular shapes, the monolith appears almost machined, its flat faces intersecting at near-perfect 90-degree angles. Early estimates suggested it could tower over 16 feet tall, further fueling its mythic aura, but here's where reality steps in. High-resolution follow-up images revealed the truth. This isn't some alien artifact, but an extraordinary example of joint-controlled erosion. The monolith is likely a fractured block of volcanic basalt, part of an ancient cliff face that crumbled away over billions of years. Mars' weak gravity and lack of tectonic activity allowed it to remain standing while surrounding material weathered into dust, leaving this singular slab to dominate the landscape. The science behind its shape is just as fascinating. Basalt often fractures along clean, geometric planes when subjected to stress, a property exploited by ancient builders on Earth to quarry stone for monuments. On Mars, these natural fractures were amplified by temperature extremes. During the day, the rock expands under brutal sunlight. At night, it contracts in the freezing vacuum. Over millennia, these cycles split the stone along its weakest lines, creating those unnervingly straight edges. Wind erosion then sand-blasted the surfaces smooth, while shadows cast by the low-hanging sun exaggerated the monolith's sharp profile. It's nature's version of a master stonemason, no blueprints required, yet the monolith's pop culture legacy can't be ignored. The 2-to-1 comparisons weren't just superficial, they tapped into something deeper about how we explore the cosmos. When we encounter the unfamiliar, our brains scramble to fit it into existing narratives, whether sci-fi tropes or conspiracy theories. The monolith became a Rorschach test, proof of alien intelligence for some, a geological marvel for others. Even scientists couldn't resist the allure. The European Space Agency jokingly referred to it as a memorial to Arthur C. Clarke in official communications. What often gets overlooked is the monolith's contextual brilliance. It sits in the Phlegra Montes region, an area littered with similar if less photogenic rock formations. Some jut like broken teeth from the regolith, others lie toppled like fallen dominoes. Together they paint a portrait of Mars' violent past, volcanic eruptions creating dense basalt layers, meteor impacts fracturing the crust, and endless dust storms sanding the debris into surreal sculptures. The monolith isn't an outlier, it's the poster child for an entire family of geological oddities, each telling its own chapter of the planet's history. Perhaps the most poetic detail is the monolith's impermanence. Precise measurements show subtle changes in its profile over just a few years. Tiny rockfalls near its base hint that even this seemingly eternal sentinel is slowly crumbling, grain by grain, under the weight of Martian time. It's a humbling reminder that the most alien thing about Mars isn't its rocks, it's the timescales on which they operate. What looks eternal to us is just a fleeting moment in a planetary saga billions of years old. So while the monolith won't be transmitting signals to Jupiter anytime soon, it embodies something far more profound, the collision between human imagination and cosmic reality. Every time we project our stories onto Mars' barren landscapes, the planet answers with its own written not in symbols, but in wind, stone, and time. And if we listen closely, those stories might just teach us more about our place in the universe than any fictional monolith ever could. Casting an eerie silhouette against the Martian sky, a strange disc-shaped shadow appeared in one of Curiosities' Rover images, instantly sparking frenzied speculation about a Mars UFO hovering just out of frame. The dark, saucer-like outline, hovering above the horizon like a classic flying saucer from 1950s sci-fi, sent conspiracy theorists into overdrive. Was this proof of extraterrestrial visitors observing our rover, or perhaps a glitch in NASA imaging system, hiding something they didn't want us to see? The truth, as is often the case on Mars, is a fascinating collision of science, optics, and the human brain's unshakable love for a good mystery. First, let's dissect the shadow itself. Unlike solid objects, which cast shadows with crisp edges when lit by Mars' unfiltered sunlight, this anomaly had a hazy, diffused outline almost like a smudge on a camera lens. That's because it likely was a smudge, or more precisely, a lens flare or dust particle catching the light at just the right angle. Rover cameras, much like our smartphones, are vulnerable to internal reflections when sunlight enters the lens at oblique angles, creating artifacts that don't correspond to real objects. Alternatively, the shadow could have been cast by a high-altitude dust cloud, lofted by one of Mars' infamous whirlwinds. These transient formations, when backlit by the sun, can project dramatic, shifting shapes onto the landscape below. But what makes this UFO especially compelling is the psychology behind its virality. The human brain is wired to prioritize potential threats, and anything ambiguous in motion, like a shadow where shadows shouldn't be, triggers hyper-awareness. This instinct, honed over millennia to spot predators lurking in tall grass, now misfires spectacularly when applied to grainy rover footage. Compounding this is the black drop effect, a visual illusion where indistinct shadows or distant objects appear to hover or warp when viewed against high-contrast backgrounds, much like the optical tricks that made early astronomers see canals on Mars. Skeptics argue that if this were an actual object in Mars' thin atmosphere, its shadow would behave differently, stretching or compressing depending on the sun's position, or showing atmospheric distortion. Instead, the shadow remains static across multiple frames, suggesting a fixed artifact, not a moving craft. And let's not forget scale. Mars' horizon appears deceptively close due to the lack of atmospheric haze, making even small camera flaws loom large in our perception. Yet here's the twist: while the UFO was debunked, the phenomenon it represents is very real. Mars does have unidentified flying objects, just not the metallic, piloted kind. Meteorites streak through its skies, leaving fiery trails captured by orbiters. Dust devils, some towering 5 miles high, whip across the plains like phantom dancers. And high-altitude ice crystals sometimes form iridescent clouds that shimmer like auroras. These natural wonders are no less breathtaking for being explainable. They are reminders that Mars' atmosphere, though thin, is a theater of constant, if subtle, drama. So the next time you spot a UFO in rover footage, pause and consider the forces at play. Mars isn't hiding alien fleets, it's playing tricks with light and shadow, inviting us to question not just what we see, but how we see. And perhaps that's the real gift of these illusions: they keep us looking closer, long after the mystery fades. From glowing orbs to floating spoons, pyramid-like mesas to rocks shaped like iguanas, Mars has served up a cosmic buffet of mysteries that blur the line between geology and fantasy. Over the past 30 discoveries, we've unraveled how wind carves faces into cliffs, how minerals crystallize into blueberries, and how shadows transform cracks into doorways. Each phenomenon, no matter how bizarre, teaches us the same profound lesson: nature is the ultimate artist, capable of crafting illusions so perfect they challenge our perception of reality. Yet for every mystery science solves, Mars unveils another. The same processes that create dragon scales also hide tunnels beneath the surface. The same winds that sculpt waffle rocks might one day reveal fossils we can't yet imagine. This duality is what makes Mars irresistible. It's a world where logic and wonder share the same dusty ground, where the answers we find only lead to deeper questions. So what's the takeaway from these 30 cosmic riddles? First, that our brains are wired to seek the familiar, even when staring into the alien unknown. But more importantly, that Mars refuses to be boring. Whether through Pareidolia's playful tricks or geology's patient genius, the red planet keeps us humble, curious, and hungry for discovery. The adventure is far from over. With every rover's wheel turn and every orbiter's snapshot, we're piecing together a story billions of years in the making. Some chapters are written in water-carved valleys, others in volcanic scars or wind-swept dunes, and somewhere in those pages might be the ultimate revelation that we're not alone in the universe. So stay curious, the next Martian mystery could be a single camera frame away, waiting to rewrite what we thought we knew. And if you've enjoyed this journey through the Red Planet's strangest secrets, don't miss what's coming next. The cosmos is full of puzzles, and we're just getting started.